Okay, here's your first mini lesson from Howie. So get used to them. They might get a little old by the end of the semester or the year, but nonetheless, hopefully they're really going to help you out. So, yes, Mrs. Howie, Science 7, a little bit of craziness going on here. You guys are going to get to know me pretty well throughout this semester and year, and you guys are going to know that I'm pretty goofy, but I love showing videos to kind of make you laugh and make you smile. Some of them have a lot to do with science, some of them not so much. But nonetheless, we're going to get into lesson 1. And I want you to guys, I really want to encourage you guys, first of all, to read the lesson and take notes before you watch this, because this could clear up a lot of questions. And when you come into the Class Connect session, you know, hopefully that you guys can write down some things that maybe you're not understanding, but at the same time, I hope this clears up a lot of your questions. So let's get going. The tools of science. And you guys are going to also know, I love to use Google Images, so I'm going to find some pretty funny little pictures for you guys. So these are my, oh yeah, these are pretty good looking, you know, tools. So I have to tell you guys, way back when I was in high school, which isn't really that long ago, but nonetheless, of course we had to wear these crazy goggles, and these are actually much better than the ones that I had to wear. And this chemistry teacher I had would make anybody who forgot to put on their goggles while doing an experiment, make them stand up on this desk and sing this horrific song about goggles. So anyways, I just thought these were kind of funny. So we are going to get our hands dirty, talk about the tools of science. So that is your first unit or lesson that we'll be talking about. So we're going to go get in deep, okay? Now, the objectives for this lesson, I like to kind of touch on these. I'll talk about these a little bit in the Class Connect as well, but it's always good for you guys to know what you're going to get out of this lesson, right? Okay, so the first thing is hopefully you're going to be able to list ways that tools are going to aid investigations. Obviously, in all investigations that we do, science related or not, we have to use tools, and they're going to help us greatly. Recognize common scientific tools, so we're going to go through some of those today, what they're used for, how to use them. We're going to know some common safety symbols associated with the scientific investigations. You'll find those in your lesson. I'm not going to go into detail in those here because you guys can see those there. And then know how to be safe in the lab and in the field, and understand how computers aid scientific investigations. Oh yeah, aren't you so excited? You better be. Okay, so observations. I found this awesome website that I actually use for my high school forensic science class, just so you guys know. And when we talk about CSI, crime scene investigation, obviously they are heavily using observations in order to solve crimes. So let me take you to this website, and I want you guys to watch this quick video. Okay, it says, and sorry, part of it might be cut off for you guys. It says, test your powers of observation with the original selective attention test. Okay, so you guys are going to see this video. It says, disclaimer, this video is hosted blah, 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 blah. So hopefully you guys are able to see this. Watch this.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla?
Did ya?
This video is from research by Daniel Simons and Christopher Chabris and is copyrighted.
Okay, so
it is available for use in talks, training, and teaching on DVDs from VisCog Productions.
So
learn more at theinvisiblegorilla.com.
Okay, so that video is definitely talking about observations. So maybe some of you guys had no idea that the gorilla actually walked through. The first time I watched the video, I have to admit, I didn't see the gorilla. I was paying so close attention to the people in the white shirt and how many times they passed the ball that I totally missed the gorilla. So the power of observation is huge. I mean, we have to take into account all things. So keep that in mind, because that's the first kind of the first step when we talk about experimentation, especially in science. So here are some tools that are commonly used, and you're going to see a list of these in your lesson, so please make sure that you are familiar with all these, that these will be used time and time and again when you're in a science class. So you have a balance, you have beakers, you have calculators, computers, graduated cylinders, hand lens, microscope, goggles, spring scale, timer, thermometer, telescope, test tube, and volumetric flasks. So all of these have different needs, different uses in the world of science, and they're very particular. And you guys have to understand that they are absolutely necessary for carrying out certain investigations and also keeping you safe. So here are some of the tools. Again, you're going to notice that there's a list of them in your lesson, so make sure you guys go over those. If you have any questions on what some of these are and what exactly they're used for, please let me know and I will go over that. Okay, so now, again, my Google images. I think I Googled like safety, and this is what I came up with. And it's like this weird, crazy dude with his elbow on fire, and he's like, ah! Okay, so anyways, I just had to make light of that. So what would you do if your arm is on fire? No, we really are going to talk about safety a little bit, but I'm going to show you guys some kind of humorous safety videos. One is super kind of a joke about it, but then the other one is kind of more music related, and it's kind of fun. So let's take a look at this. All right, hold on one second. Let's get that. Now watch this, and hopefully you'll crack up a bit.
Welcome aboard. It's 2007, and we are more committed to your safety than ever. And that's why we'd like you to pay careful attention to this important safety information. First, please make sure that your seatbelt is securely fastened. Seatbelts can be purchased for $5. To fasten, insert the metal fitting into the buckle and tighten the buckle by pulling the loose end away from you. To release, purchase a release flap for $7. Now I know what you're thinking. We've never paid for seatbelts before. Once we've reached our cruising altitude, your flight attendant may or may not go down the aisle with snacks. If she chooses to, each passenger will be given a single peanut. Lavatories are located at the front and the rear of the airport. Please take a moment to look at your safety pamphlet. The charge for looking at this pamphlet is $3. The charge for looking at this pamphlet and putting it back quickly is $4. Should there be a rapid change in cabin pressure, oxygen masks will automatically drop from the compartment above your seat, free of charge. Place the mask over your nose and mouth, and to start the flow of oxygen, pay your flight attendant $75.63.
I can't breathe.
As always, exact change is appreciated. Now I know that some of you are still concerned about getting there safely. Enjoy your flight.
Okay, there was one kind of making fun, and it's kind of funny. But here, this is another one that's not quite as funny, but it's entertaining. So this is our safety wrap. So get a look at this.
Safe, yeah, I got my hard hat on. Safe, I got my FR. Safe, I got my gloves on. Safe, yeah, I don't care what you gon' do, but as long as you and your crew stay safe. I got my safety vest. Safe, yeah, I got my glasses on. Safe, I got my steel toes. Safe, I got my chalks down. Safe, even got my cones out. Safe, I don't care what you gon' do, but as long as you and your crew stay safe. That's right, that's life, man, you gotta play the rules. Living dangerous, but you tryna play the fool? I'm the reason why being safe is cool. Shiny hard hat, steel toe in my shoes. FR clothing and my glasses approved. My whole crew here is safe. Why is that? Because I got a pretty face and being unsafe is ugly. Plus I got a family at home who loves me. I got my safety vests on all the time to make sure you see me all the time. I circle for safety before I drive. My seatbelt's on before I drive. And I use a spotter when I'm backing up. Why is that? Because I'm backing up and that's safe. I'm focused. Safe. I got my mind right. Safe. Yeah, I got my hard hat on. Safe. I got my FR. Safe. I got my gloves on. Safe. Yeah. I don't care what you gon' do, but as long as you and your crew stay safe. I got my safety vest. Safe. Yeah. I got my glasses on. Safe. I got my steel toes. Safe. I got my chalks down. Safe. Even got my cones out. Safe. I don't care what you gon' do, but as long as you and your crew stay safe.
Dennis! Dennis! Focus on the job.
So, okay, I kind of make light of the whole safety issue, but really that is very important. Obviously, according to that video, I mean, in pretty much all instances in all jobs, you have some bit of safety to take into consideration. Well, in the world of science, when you're using many different tools, different hazardous materials possibly, you have to take into account safety. So again, there's another kind of a practice activity that's not graded that I'd really like you guys to focus on. Make sure that you understand the safety precautions that you need to take when we're doing experiments, but just in the world of science in general, okay? So you guys are going to have an assignment coming up on technology. Now, computers and technology obviously kind of go hand in hand. We use technology for most everything. And considering we're in an online school, you guys are on a computer right now, so hopefully you guys are kind of understanding that correlation. Now, okay, of course now you guys aren't looking at computers like this. This is back when I was like a kid, like the first, I felt like it was like the first computer ever. But no, we have amazing technology when it comes to computers. So you guys are going to delve into that a little further. You're going to do some research on kind of what kind of technology is used in science on a daily basis, and also kind of what kind of technology you guys use on a daily basis in a more personal level. But computers and technology go hand in hand, and we use them a ton in science. So variables and constants. We are going to touch on this pretty much when we talk about this in the Class Connect, because this is a component of the experimental phase and just kind of scientific method and scientific inquiry that a lot of people don't really understand. Variables and constants. So when we are testing something, you're always going to have some bit of variables and you're going to have a constant. And a constant is very important because a constant we kind of think about as a control. Constant is something that remains unchanged. So we think of that as a control sometimes, where we basically look at something that has not changed based on, like take for instance, you have an experiment that you're dealing with adding different types of chemicals. Well, your constant it's something that remains unchanged. But I guess I don't want to confuse you guys that a control isn't always your constant, but a constant is something that's going to remain the same in each experiment. So say for instance you're adding 10 milliliters of water to each of the test tubes. That's going to be something that's constant, that stays the same. But a variable might be the different types of material you use. So maybe within your 10 milliliters of water, you're adding a protein in one, you're adding a lipid in another, and so forth. So again, I just want you to know the difference between a variable and a constant. But when we talk about constants, sometimes we get into the controls, where the control is something that you can compare it to. So we'll touch on that more in class. I don't want to confuse you guys too much, but that is in your lesson. Make sure you guys read through that, and let me know if you still have more questions, and we'll give some really good examples. So speaking of examples, before we go into the vocab, I hope some of you guys have watched Mythbusters in the past. It's a show that I absolutely love. And listen to this quick little experiment, because they talk about kind of the controls, the variables, and so forth. And we'll talk about that again. Like I said, we'll finish up with that in our Class Connect. But watch this, and it kind of gives you a little bit more visuals on what variables and constants and variables and controls are.
The Mythbusters are going to have a blast.
The most common
theory about what's going on in this reaction between the candy and the soda is what's called nucleation. Basically, the idea is that the surface of the candy is covered with microscopic pits and lots of more surface area than you can actually see. And each little pit, each little corner provides what's called a nucleation site, or a place where a carbon dioxide bubble can form and escape.
Look at a Mentos close up, and it's like the surface of the moon. And that might be the candy key. Drop one in cola, and every tiny crater provides a site where a CO2 molecule can change to gas. Because Mentos are so pitted, the theory is that millions of CO2 bubbles are formed in a very short space of time. And because the candy sinks and this rapid release of gas happens at the bottom of the cola, you get that famous fountain. To test this nucleation theory, they're going to start with a control. One regular mint Mentos dropped in soda water. And sure enough, it gets the bubbly party started. Now, to do a comparison.
These two candies are made by the same manufacturer, and as far as I'm aware, even using the same process. But the colored version of this actually has a glazing over it. It's a wax coating or a sealer that inhibits the nucleation process that the other one achieves quite readily.
The shiniest surface should lower the nucleation sites, meaning less of an immediate eruption.
That's not doing anything more than the wall of the plastic bottle itself.
Sure enough, with the smooth Mentos, there ain't no whiz with the fizz. The Mythbusters can say they finally cracked the case of the candy and cola cascade.
Okay, so when you think about that video, think about the variables. When you think about the different types of Mentos, you have the regular plain Mentos and that colored Mentos. Those are variables because obviously there's a difference between those two. Your constant would be, it's put in soda water. Both of them were put in soda water, the regular white mint one and the green one, whichever flavor that might have been, were both put in the plain soda water. So that's your constant. Okay, they also use that as a control, okay, to compare that to. But so that you got a good kind of a visual of what variables versus constants means, okay? So basically, that's kind of what is encompassed in your first lesson. Again, make sure you guys read through that. Let me know if you have any questions. I hope you're taking notes because those will come in very handy for your quiz. And this is the last thing that I want to make sure that you guys are really taking time to look over, your vocab, okay? So there are usually 1 or 2 activities that surround your vocabulary. You need to go over those. You have to understand what a calculator is, what safety goggles do, telescope, test tubes, and your beaker. Now, obviously, those are pretty easy, and you're like, yeah, that's kind of whatever, you know. But some of them, as we go on through the different lessons, you might not know all of them. So make sure you guys take the time because you'll see those in your quizzes. Okay? So that's a wrap. Now, that was your first lesson. If you have any questions at all, you guys know I'm here for you. But most importantly, you'll see me back again for lesson 2. So until then.